Hello students, I am Samarth Doshi and today we are going to learn chapter number 1, real numbers. In this chapter, we are going to find HCF and LCM by two different methods. Now first topic we have in this chapter is Euclid's division algorithm. Now we want to find HCF using this method. Before that, we should know that formula A equals to BQ plus R, where A equals to divider, B equals to divisor, Q equals to quotient and R equals to remainder. Clear everyone? Also you should understand that if we divide 24 by 3, you will get 8 here. So here 24 and here 0. That means if we divide 24 by 3, quotient you get is 8 and remainder you get is 0. Same thing. If we divide 25 by 3, so again 8 here, again 24 here, and now remainder is 1. If we divide 26 by 3, so again 8 here, 24 here and 2. And if we divide 27 by 3, so here it will be 9, because 9 3 is a 27. Now 28, divide that by 3, so 9 3 is a 27, remainder 1. If 29, then 3, 9, 27, so 2. At last, if we have 30, then 3, 10, 30, 0. We know all this division. Clear? So by dividing 3, all these numbers, remainder you get 0, 1, 2, 0, 1, 2, again 0 and continue. That means when we divide by any number, remainder is always less than the divisor. Remainder is always less than divisor, and remainders can be 0 or more than 0. This formula you should remember. Remainder is always 0 or more than 0, but always less than divisor. So here divisor 3, so remainder is 0, 1 or 2. Clear? Now by this method, if question asked is find out HCF by Euclid's division algorithm. So first thing, any two numbers are given, because if you want to find HCF, so minimum two numbers should be there for which we are finding HCF. So let two numbers are A and B respectively, and always you should take larger number as A. That means if question asked is find out HCF of 36 and 27. So which one is larger? So 36 is larger. So instead of 36, we should say A, and instead of 27, we should say B. Express these two in the equation of A equals to BQ plus R. How? 36 as it's it here. Instead of B, 27. Now what you should do? Divide 36 by 27. Here you will get 1, 27, so remainder 9. So instead of quotient 1, and instead of remainder 9. Now write down 27 here. So 27 and 9. Now in this method you should remember, first step, given two numbers, larger number take it as A, smaller number take it as B, and express those two numbers as A equals to BQ plus R. After expressing in that form, again you should do that step only for divisor and remainder you get. Now 27 and 9. 27 is divisor and 9 is remainder. Same method, same step for now these two numbers. So 27 is now A, 9 is B. Understood? 27 as A now, 9 as B now. So again same procedure. 27 divided by 9. So 3, 27, 0. So 9 3s are 27 plus remainder 0. You should do this process until you get remainder as 0. Here we get 0 as remainder. Clear? So when you get 0 remainder, then you should see in the second last step. So this one is remainder 0. So second last step here. In second last step, whatever remainder you get is our HCF. So HCF of two numbers 36 and 27 is 9. Clear? Now remember, when question we have is find HCF of 150 and 39. So always you should remember first that when two numbers are there, then only we can use Euclid's division algorithm method. This method is applicable only for two numbers. Always remember, this method is applicable for only two numbers. Now question we have is find out HCF of 150 and 39. So which one is larger? Clearly we can say 150. So take 150 as A and 39 as B. So 150 equals to 39. So divide 150 by 39. Here you will get 39 3s are, it will be 117. So remainder is 33. Clear? Now, which second step we have? Same procedure for divisor and remainder. So now 39 here, 33 here. So again divide 39 by 33. 33 ones are 33. So remainder is 6. Clear? Again remainder 6, not 0. So again we do this procedure. 33 and 6 now. So take 33 as A, 6 as B. So now divide 33 by 6. 6 5s are 30. So again remainder is 3. So 6 5s are plus 3. Clear? Again now these two. So 6 equals to 3. If we divide 6 by 3, 2, 6 and 0. So 3 2s are 6 plus 0. Here you get 0. We are doing this process until remainder is 0. After getting remainder is 0, again we need to see second last step. In second last step, which one is remainder? 3. So HCF of 150 and 39 equals to 3. Clear everyone? Now, new question we have is find HCF of 4052 and 12576. This question is of textbook. Example 1. Now, which one is bigger? Clearly, it is 12,576. So, instead of B, 4052. If we divide these two, 12576 divided by 4052. So, here it will be 3. So, 12,156. So, remainder will be 420. I am doing directly, but you should do it in rough work. This all work should be in rough work. Clear? This division work you should do in rough work. This one is proper presentation. 12576 at A, 4052 at B. After dividing, quotient 3, remainder 420. You should write like this, and this procedure in rough work. Now, second step. Remainder is 0? No. So, now for these two. 4052 equals to 420 multiply by 9. 420 multiply by 9. You should do like here. 420 multiply by 9. So 0, 9 to the 18, 1 power, 9 4 the 36 and 1, 37. So 4052 minus 3780. It will be 272. Now again same procedure for these two. So 420 equals to 272, 1 is 272 plus 148. Again procedure for these two. 272 equals to 148, 1 is 148 plus 124. Again 148 equals to 124, 1 is 124 plus 24. Again now for these two. 124 equals to 24 5 is 120. 24 5 is 120. So remainder is 4. Again now for these two. 24 equals to 4 6 is 24 plus remainder 0. 1 2 3 4 5 6 7. This all step you should do. Now you get remainder 0. So in second last step, remainder we have is 4. So your proper answer you should write like HCF of 4052 and 12576 equals to 4. This one is answer. Clear? Example 2 in textbook we have is, so that any positive even integer is in the form of 2q and positive odd integer is in the form of 2q plus 1. This we need to show. So by showing just a question we have a equals to 2q plus, only 2q is there. So what should be there? Plus 0. And odd form we have 2q plus 1. So if we express any integer be a, so any integer we can write a equals to bq plus r. Yes or no? Earlier we learned that a equals to bq plus r, where a is dividend, b is divisor, q is quotient and r is remainder. Now if any integer be a, so a equals to bq plus r. Just look here, 2q and 2q plus 1. So if we take b as 2, let b equals to 2. So a equals to 2q plus r. Clear everyone? Understood? Earlier we also learned that remainder is always less than divisor. Clear? Here divisor we have is 2. So remainder should be either 0 or 1. So r equals to 0 or 1. If we take r equals to 0, let r equals to 0, then this number now a equals to 2q plus 0, 2q. If we take r equals to 1, then a equals to 2q plus 1. Now a equals to 2q. Now this number is multiplied by 2, then this number is even. Now this number is multiplied by 2, so this portion is even. And even number plus 1, it will become odd. Clear? So 2q is even number form and 2q plus 1 odd number form. So answer you should write, hence 2q is form of even positive integer, even positive integer, and 2q plus 1 is form of odd positive integer. Integer. Clear? What you should take? Just take r equals to 0 and 1 and b equals to 2. You should write answer from this step. First you should write, let any integer be a. So a equals to bq plus r. Then from question, take b equals to 2. So a equals to 2q plus r. Now we know that remainder is always less than divisor. So r equals to 0 or 1. So once take r equals to 0. So you get a equals to 2q, which is even number. Now take r equals to 1. So a equals to 2q plus 1, which is odd form. So at last you need to write, hence 2q is form of even positive integer and 2q plus 1 is form of odd positive integer. Now in textbook example 3, question we have is, show that any positive odd integer is of the form 4q plus 1 and 4q plus 3. So now you can do by yourself that. Question we have is 4q plus 1 and 4q plus 3. 4q plus 1 and 4q plus 3. By seeing these two, I would suggest take b equals to 4. Directly we can say b equals to 4. Now do by yourself. Start answer as, let any positive integer be a. So a equals to bq plus r. So now take b equals to 4. So a equals to 4q plus r. Now divisor is 4. So remainder can be 0, 1, 2 or 3. Just put the value. R equal to 0, then 4q. R equals to 1, then 4q plus 1. R equals to 2, then 4q plus 2. And R equals to 3, 4q plus 3. Just do by yourself and show that 4q plus 1 and 4q plus 3 are odd integers. Also from textbook, example number 3, example 4, in exercise 1.1, question number 1, all 3 questions. Just we have question as, find out HCF of given two numbers. apply Euclid's division algorithm method. Clear? And question number 2 and question number 3 of exercise, that also you should do by yourselves. Clear? Now question number 4 of exercise 1.1. In this question we have, show that square of any positive integer, square of any positive integer in the form of 3m or 3m plus 1. This we want to prove. We need to show that square of any positive integer. Just look here, square of any positive integer is in the form of 3m or 3m plus 1. So answer, first step, always you should write, let any positive integer be a. So a equals to bq plus r. Clear? Now from question we can say, let take b equals to 3. So a equals to 3q plus r. Understood everyone? Now from question we can say, take b equals to 3. So a equals to 3q plus r. So what is the value of r? Yes. So r is always less than divisor. So r is always less than 3. So r can be 0 or 1 or 2. So first step you should take, let r equals to 0. If you take r equals to 0, then a will become, that implies a equals to 3q. Now when r is 0, our integer become 3q. But in question we have square of integer. So square of a square, square of 3q, 9q square. So we can represent 9q square in the form of 3 in bracket 3q square. Only in multiplication relation. We can split 9 as 3 multiplied by 3. Clear? So why we are splitting this? Because we want in the form of 3m. So we are taking one 3 outside and other 3q square. Clear? So 3 multiplied by 3q square. Now you should mention, let 3q square as m. 3q square as m. So a square will become 3m. Clear? So when r equals to 0, square of any positive integer in the form of 3m. But for 1 and 2 also you should prove like this. How? Now take r equals to 1. That implies a equals to 3q plus 1. So a square equals to 3q plus 1 whole square. Always remember, when we are doing square both side, then here square of a square and 3q plus 1 square, it will be whole square. Clear? So now a square as it is. Now here again we know that x plus y whole square formula, identity, x plus y whole square, x square plus 2xy plus y square. So 3q square, 9q square plus 2 into 3q, 6q, 6q into 1, 6q plus 1 square, 1. Now from these two we can take 3 common. We want only 3 here. Look here, 3m plus 1 type, 1 is here. So now from these two only take 3 outside. So other inside 3q square plus 2q, and we are not taking any common from 1, so 1 is single term at last. Understood? What we are doing here, just we are taking 3 common from these two. So after taking 3 common, it will become 3. After taking 3 common, it will become 2, q square and q as it is. As we take 3q square as m here, now take 3q square plus 2q as m. So a square will become 3m plus 1 type. And last procedure, that r equals to 2. That implies a equals to 3q plus 2. So square of integer a square, 3q plus 2 whole square. So a square equals to, again x plus y whole square formula. So x square 9q square plus 2 into 3q 6q, 6q into 2 12q plus square of 2 4. Now again here we want 3 outside and we want either 0 or 1 at last. So we need to split 4 as well. How we can split 4? 4 we can split 9q square plus 12q plus 3 plus 1. So that from these 3 terms, 3 common, it is 3q square plus 4q plus 1 plus 1. Understood everyone? Now in last step we get a square equals to 3 in bracket 3q square plus 4q plus 1 and plus 1 again. As we took earlier, now take 3q square plus 4q plus 1 as m. So now put it here. So a square equals to 3m plus 1. So when r equals to 0, then square of any integer in the form of 3m. And when r equals to 1 or 2, then square of any positive integer in the form of 3m plus 1. Hence, so clear? Always you need to write answer in statement. You should write like, hence we showed that square of any positive integer is in the form of 3m and 3m plus 1. Understood everyone? Now question number 5 in exercise. So that cube of any positive integer is in the form of 9m, 9m plus 1 and 9m plus 8. Now look at here. Remainder is nothing here. 9m plus 0. So remainder is 0. Now here remainder is 1. And here remainder is 8. Understood? If we are taking any number as a, so a equals to bq plus r, so it is 9m plus 0, 9m plus 1, 9m plus 8. So here remainder is 0, here remainder is 1, and here remainder is 8. But here we want cube. So cube root of 0, 0. Cube root of 1, 1. Cube root of 8, 2. So remainders are 0, 1 and 2. Clear? If we are taking b as 9, then we can take. But we are having cube. So it is 0, 1, 2. So remainder is 0, 1, 2. Then divisor should be, if remainder is 0, 1 or 2, then divisor should be 3. Clear? So first step, let any positive integer be a. Let any positive integer be a. So a equals to BQ plus R. Now take B equals to 3. That implies A equals to 3Q plus R. Divisor is 3 now. So remainder is, that implies R equals to 0, 1 or 2. Clear? Now take R equals to 0. If we take R equals to 0, then A will become 3Q only. Clear? Now we want cube of integer. So cube of A cube. Cube of 3, 27. Cube of Q cube. So a cube equals to 9 in bracket 3Q cube, because we want in the form of 9m. So we are taking 9 outside. So a cube equals to 9m. Thus you need to take 3Q cube as m. Clear? Now take R equals to 1. That implies A equals to 3Q plus 1. Now cube of A. So a cube of 3Q plus 1 whole cube. Now A plus B whole cube formula. A plus B whole cube. Formula we have is A cube plus B cube plus 3A square B plus 3AB square. A cube plus B cube plus 3A square B plus 3AB square. In other manner we can write A cube plus 3A square B plus 3AB square plus B cube. So A cube, instead of A we have 3Q. So 3Q cube, 27Q cube plus 3A square B. So 3 into square of 3Q, 9Q square. So 3 into 9Q square, 27Q square. 27 into 1, as it is 27Q square. 3AB square, 3 into 3Q, 9Q. 9Q into square of 1, 1. So 9Q as it is, plus square of cube of 1, 1. From this term we can take 9 common. So it is 3Q cube plus 3Q square plus Q plus 1. Now take 3Q cube plus 3Q square plus Q as m. So A cube will become 9m plus 1 type. Clear everyone? Understood? Now if we take R equals to 2, then A will become 2. Now cube of A cube, which is 3Q plus 2 whole cube. Again A plus B whole cube formula. A cube, which is 3Q cube, 27Q cube plus 3A square B. So 3 into 9Q square, which is 27Q square, multiply by 2. So 54Q square plus 3AB square, 3 into 3Q, which is 9Q. 9Q into 2 square 4, which is 36Q plus cube of 2, which is 8. Now from these three terms we can take 9 as common. So here 3Q cube plus 6Q square plus 4Q plus 8 single. Clear? Now take these 3 as m. So A cube equals to 9m plus 8 type. Clear everyone? So when R equals to 0, A cube we get is in the form of 9m. When R equals to 1, A cube we get in the form of 9m plus 1. And when R equals to 2, A cube we get 9m plus 8 form. Clear? If you have any doubt, then comment. Now for the next topic, this see the next video. In that video we are going to learn second method to find out HCF and LCM.